Hello and welcome to today's geometry lesson. So we have been doing lessons on transformations and we did reflections, and now we're moving into rotations. So a rotation, sometimes also called a turn, is a transformation in which a figure is turned about a fixed point called the center of rotation. A lot of times when we do our rotations, we're going to be rotating around the origin, but this is not always the case. So it's always a turn about a fixed point, and that is called the center of rotation. So angle of rotation is formed by drawing the rays from the center of rotation to a point and its image. So if we have an image to a point, so whatever they want us to do, if they want us to do a 90-degree turn, then what we would do is we would take this point and draw it to the point, and now we need to make this a 90-degree angle so that this piece right here and this piece right here are making the same angle as the angle up here that we had, and this distance is equal to that distance. So this is where that point would rotate to. So we always do a rotation counterclockwise. All right, so is this a rotation? So here's the fixed point, and are they rotating around that fixed point? So it looks like in letter A that looks like a rotation, and letter B does not look like a rotation. That looks more like a reflection. So that is a flip. All right, unless noted, notice I said that there are always counterclockwise rotations. So here we're going to do an example, and they want us to do a 90-degree counterclockwise rotation. So we take point A, and we go from here to here and then to the best of our ability. So I'm going to measure this out, and to the best of my ability, I am going to make this be a 90-degree corner so that it comes at the same length. And I need this length to be the same as this length, and this is where A prime is going to be. Then I do the same thing from B. Now I have this long of a line, okay, but I need that to still be a 90-degree turn. So it needs to be a 90-degree angle, and I need this piece to be the same length as this piece. So this red piece needs to be the same length, and this is where B prime would be. And then you do that again for C. So you draw C to the point P, and now I need that to be a 90-degree angle. And so whatever length I have this piece to be, this piece needs to be the same length. So this is where C prime would be. And then you connect them, A to B to C, and here's where your rotated triangle would be. So it all goes back to that point, and it needs to be at the same angle that they're telling you, and those pieces need to be the same. All right, so see how I rotated original A back to the other one, and the distances are the same. All right, rigid motion. So we've talked about this with translations and with reflections. So it does not change the shape or the size. So is a rotation an isometry? Does it stay to be the same shape and the same size? And the answer is yes. A rotation is also a rigid motion. All right, so now we're going to go through some special cases of a 90-degree rotation. So we're going to start at this ordered pair 2, 3. So 2, 3, that point right there, 2, 3. Now we're going to do a 90-degree. So if I think about the slope of this line right here, the slope of that line is up 3 over 2. So if we're going up 3 over 2, remember anything that's perpendicular to that is going to be negative 2/3. So if I go up 2 over 3, this point should now be where my 90-degree turn is. So what is this ordered pair right here? Well, that ordered pair is 1, 2, -3, and a +2. So that would be your 90-degree rotation there. So now what happened in the 90-degree rotation? What happened? This x value went into the y spot, and the y value went into the x spot and changed signs. So what is that rule? So a 90-degree rotation rule. So I like to write my rules as x's and y's. So it became what? The opposite of whatever y was. And then the x value stayed as the x value. 2 stayed 2, but the y came in front and it switched signs. So the rule for a 90-degree rotation is the opposite of y, comma, x. All right, now what would it be for a 180-degree rotation? So go to 4, 1, 1, 2, 3, 4, 1. So we have that ordered pair right there, 4, 1. Now if we're going to do a 180-degree rotation, does that make sense that this is going to be 1, 2, 3, 4, and down 1 to get that nice perfect straight line through there? So down 1 over 4, down 1 over 4. So now what is this ordered pair? Well, it looks like -4, -1. So what happened here for the 180-degree rotation? Did x and y stay in the same place, but did they change signs? So the rule for a 180-degree rotation is going to be the opposite of x and the opposite of y. So they stay in the same place, they're just going to switch signs. And then we also have that 270-degree rotation. So if you guys do this different, it's totally fine. I'm just showing you how my brain works through these. And sometimes you guys like to just graph everything all the time. I like to know what those rules are. So a 270-degree rotation is going to go, so 90 degrees, 180 degrees to this 4, 1. So now if this is over here 1 unit away, it's going to be 1 unit away over here, but down here. So what point is that? That looks like 1, -4. So if we're at 1, -4, what is the rule? What happened over here? Well, it looks like x went to the y spot and it changed sides, and the y just came in front. So the 270, the y moves in front but keeps the same sign, and the x switches to the back and it also changes signs so that we have a negative x. All right, let's put some of this into use. Oh, here are the rules, and they write it with A's and B's, but it's exactly the same thing we just went through with me counting with the X's and the Y's. Just works for my brain better with the X's and the Y's. All right, so we have this quadrilateral RSTU, and they want it to rotate its image after 270 degrees. So with it being a 270-degree rotation, we are going to use that rule of y minus x. So I personally don't like to graph mine. You can certainly graph it afterward if you need to, but what I would like to see on your test and any assessment is what that ordered pair going to be. So R prime. If it's 3, 1, the y comes in front as a 1, and then we put the opposite of x. Okay, now you try the next one, s. S prime, what is s going to be? So I take that y value, bring it in front, and then the s switches signs, or the x, I should say. T prime is going to be, I take the y value in front, so the -3, and that's a 5, so now it becomes -5. And then u prime is going to be, take that y value, bring it in front, and the x goes in back, and it switches signs. So these should be the 4 ordered pairs when we do a 270-degree rotation around the origin. All right, so let's just check u is what? -1, -2? So u is -1, -2. So this is what it looks like as the graph. All right, so graph RS with endpoints and its image after the composition. And remember, composition is 2 or more transformations. So the first transformation that they're going to have us do is a reflection around the y-axis. And remember from yesterday, we did round a reflection over the y-axis. The y stayed the same and x changed. So this is x is going to change signs and y stays the same. So r prime is going to be -1 and y stays the same. S prime is going to be that we're going to do the opposite of x and y stays the same. So that's your reflection. Now the rotation around the 90 degree is going to be that we're going to do the opposite of y and then x. So I have to start now at my images. So what I've already done, the reflection across the y-axis. Now I have to do double prime because it's a composition, it is the next thing. So this time what I'm going to do is take the y in front and it's going to change signs, so it becomes 3, and then the x value stays the same, so we have -1. And S double prime, remember we're starting from here. So we're going to do the opposite of y, so the opposite of y is going to be a 6, and then the x value is going to stay the same. So the end result is going to be this right here. So S is at 6, -2. All right, I think it skipped it there. So S is at 6, -2. So here we go. 6, -2 is what we said that last one was going to be. All right, the last thing that we need to talk about here is rotational symmetry and a center of rotation. So if you think about a ceiling fan, can you rotate it some sort of degree that is less than 180 degrees and that the fan is exactly on top of itself? So you can see here when it has 4 spokes that we can rotate it 90 degrees and you cannot tell any difference between the first fan and the last fan. That means it has 90-degree rotation. So do you see if we do in the middle at 45 degrees, do you see how we've got the petals coming in here in the middle? And you can tell that it's at a different rotation. So 45 degrees is not a rotational symmetry for this, but we can rotate it 90 degrees and 180 degrees to consider that rotational symmetry. So a parallelogram, can we rotate that at all to have any rotational symmetry? And for that one, I believe you can rotate it 180 degrees and it'll be exactly on top of itself. How about that octagon? Is there any amount of degrees that we can rotate it so that it is on top of itself? And what about that trapezoid? So the parallelogram you can see has a 180-degree rotation to get on top of itself. Whereas the octagon, if I rotated this point to this point, you wouldn't see any different. So if we take 360 and divide by 8 for this, because it's a regular figure, I think we end up with 45 degrees. So we can rotate that every 45 degrees until we get to 180. So it has 45-degree rotation, 90, 135, and then 180. The trapezoid does not have any, because even if we do 180 degrees, we'd have the short side on top and the long side on the bottom. That's not exactly the same. So this does not have any rotational symmetry. All right, and that brings us to the end. So good luck on your homework. Remember, this was lesson 4-3, talking about rotations.